Okay, so this is part two, and in part two we have to go through the fourth main important part of CPU architecture. Okay, so the fourth part is system bus, and there's three types. Okay, there's address bus, data bus, and control bus. Okay, so the address bus, one second. Yeah, so the address bus, like the name suggests, basically helps to transmit signals related to the address. Okay, so it transports address from MAR. MAR stands for Memory Address Register. So there's an address here and it's an address bus. So, obviously MAR is what uses the address bus. Okay, so it transports address from MAR under the CU's directives. CU is the control unit, and we learned in part 1 that CU manages data flow and it synchronizes processes and helps with the execution of programs, right? So under the CU's directives, it transports addresses from the MAR to memory locations. Okay, and this is unidirectional, which means that it can only move from A to B. It can only move in one direction. It cannot move in this direction. Okay. Data bus carries data, like the name suggests, and it is bidirectional. Control bus transports signals between the CU, between the control unit, and any other component within the system. Okay. So it's pretty simple. Just remember address bus, data bus, control bus, and the name basically tells you what each of it does. So address bus transports the address, data bus carries data, and control bus transports signals between the control unit and any other component within the system. Okay. Now moving on, we have factors contributing to system performance. Okay. Now there are four factors. Number one is clock speed. So the higher the clock speed, the better the performance. Okay, number of cores. Having multiple cores, when you have multiple cores, it allows processors to handle multiple tasks at once. Okay, multiple cores equals multiple tasks at once, which obviously means that it is better system performance. Okay, usage of cache memory is basically like a temporary memory place. Okay, so cache memory stores frequently accessed data. Cache stores frequently accessed data and instruction from the RAM. So the performance is going to increase because this is a very short access time memory, right? So performance increases with increased storage size of cache and increased rate of access. The rate of access also increases slash the access time. The time it takes to access the data from cache memory is higher, okay, which means it saves time and your system performance is better. Bus width also, if your bus width is higher, the system performance is better. An example of this is that sometimes they might say that suppose a word length is 16 bits. Okay, suppose it's like 0 0 0 0 1 1 1 1 and 0 1 0 1 0 0 0 0. Okay, suppose this is your word length. Okay, so if your bus width is 8 bits, this is 16 bits, right? Suppose your data that you want to transfer is 16 bits, and you say that your bus width is 8 bits. This means that this data has to be sent in 2 blocks, okay? Because the bus width, it can only handle 8 bits at once. So it's going to send this separately, okay? So it's going to send it in 2 blocks. So words to be transmitted by 2 consecutive data transfers, and this will affect your system performance. So the higher the bus width, it is better, because if your bus width was 16, then in just one block, in one transfer, I could have transferred all the data. But here, because my bus width is 8 bits, I had to split this up into 2, and that's going to take a lot of time, right? That's going to take more time than just sending this in one go if my bus width was 16. Okay, so that's it for that. Now moving on, we're almost at the end of this chapter. Moving on, we need to study about I/O ports. Okay, IO ports is basically short for input output ports. Okay, so IO ports. In IO ports, the basic idea, okay, I'm gonna draw like a diagrammatic structure so that you guys can understand. So suppose you have three input devices. Okay, each of these are gonna be connected to ports. Okay, port. Okay, and each of these ports are gonna be connected to a central device controller. Okay, and that device controller is going to connect your input devices to the CPU. Okay, so that's the basic idea. So your input devices are going to be connected to ports, and these ports are going to be connected to a device controller, and that is going to be connected to your CPU. Okay, now sometimes we can also say your IO port of an integral system. Okay, internal system, IO port of an internal system. Okay, that's one. And then you have an IO port of external or peripheral system. Okay, so an example of this is like touchpad, and this is a Bluetooth mouse, because a touchpad is built in and a Bluetooth mouse is external, right? So this is gonna be connected to your input port, internal port, internal port, and this is gonna be connected to an external port. And now again, both of these will be connected to a device controller, which is connected to the CPU. Device controller, which is connected to the CPU. Okay, so this is like the basic idea of this whole thing. Okay, now there's only two more things that we need to learn, which is about USB and the fetch, decode, execute cycle, FDE cycle. Okay, so let's do our USB first. Okay, so for those of you who do not know, USB is short for Universal Serial Bus. Universal Serial Bus is your USB. Okay, so the main idea of USBs is that it allows plug and play by providing a standardized interface that automatically detects and configures compatible devices without requiring any manual driver installation or programming. So our main point is that it allows plug and play, right? So it allows plug and play. And our second point is that it has a standardized interface. So standardized interface that automatically configures compatible devices. No manual driver instructions are required. No manual driver installation or programming required. So basically what this means is, suppose there's a USB. Okay, this is a USB, and I want to connect it to a laptop. Okay, I can either connect it to a laptop or like a TV, right, in the HDMI port. So basically what a USB does is it allows this plug and play feature, which basically has the capability of automatically configuring the device that it's connecting to. Okay, so usually when you're connecting some device, okay, when you're connecting something to another device, you need these installation like a manual. Okay, you need a driver installation or a programming which is required. Okay, and each of it is unique, right? But for USB, it will like automatically, it's gonna detect and configure whichever device that it's connecting to. It doesn't need that manual driver installation or programming. Okay, so it automatically configures, which is a good thing about USB. Another thing is that USB allows for a structured chain of connections, enabling the attachment of multiple devices to a single USB port through the use of hubs. Okay, so if you use a hub, you can connect multiple devices to a single USB port. Now, there are two types of outputs, right? So if you want to output something, you can do it in two ways. You can either use VGA or you can use HDMI. Okay, so VGA offers high quality screen display. High quality screen display, but this lacks audio compatibility. And on the other hand, HDMI offers visual and audio compatibility. Offers visual and audio compatibility. So if you just want to project like a video that has no sound, you can use VGA because it's high quality screen display. But if it's a movie, then you need to use HDMI because it offers visual plus audio compatibility. Okay, so if you want to output something, you can connect VGA to your output, or you can connect HDMI to your output. And if you want to input something, we learned here, the input is connected to a port, the ports are connected to a device controller, and that is connected to a CPU. So without looking, let's do that thing again. So for input, you're gonna have input devices, input, you're gonna connect these two ports, port, and these ports are connected together to a device controller, which is connected to the CPU. Now, if you have an internal input and an external input, the internal input is connected to an internal port, external input is connected to an external port, and again these are connected to a device controller, which is connected to the CPU. And for output, you have two options. You can either use VGA, which is only video compatible. It offers high quality screen display, but it lacks audio compatibility. Or you can use HDMI, and both of these can be used for outputting your result, like your media or whatever. Okay, and the last part of this chapter is the fetch, execute, decode cycle. Fetch, let me make that thicker. Fetch, execute, decode cycle. Okay, now this is very important. It comes up in like fill in the blanks or as a long answer question, so please pay attention to this. Okay, so PC holds address for next instruction. That's the first thing. PC holds address for next instruction. Actually, I'll write down all the steps and then I'll explain it. Okay, so there are 7 main steps, and I think in like most of the marking schemes, step number 5 and 7 is not very important, but it's good to know because sometimes they might ask for it. Okay, so number 1 is that PC holds address for the next instruction. Okay, PC holds the address for the next instruction. Then this address on the PC is transferred to the MAR. MAR is the memory address register. The MDR stores the instruction stored at the address indicated by the MAR. The PC is incremented by 1. It's never decremented, it never changes, it's always incremented by 1. Or sometimes a jump condition is executed, which means that the incrementation can increase by 2, 5, 10, etc. Okay, but usually it's incremented by 1, but sometimes this jump condition is executed. MDR contents are copied to the CIR, which is the current instruction register, and then the control unit CU uses the instruction in CIR as input. Okay, so what happens is, first, suppose this is your CIR, this is your PC, this is MDR, and this is MAR, and the address here, the location is 10. Okay, so I'm gonna give you guys an example. So first, the PC holds address for next instruction. So suppose 1 is what's in the PC. Okay, so 1 is the location of the next instruction that's gonna happen. Okay, so you're gonna be given like a table with a lot of instructions, and there's gonna be numbers beside this. Okay, and these numbers are the address. Okay, so I'm saying that 10 is the address for this MDR. Okay, so 1 is the PC. The PC says 1, which means this address is transferred to the MAR. Okay, so this is transferred here. Now let's say the PC's, we've loaded 10 into the PC. Okay, so the next thing that's going to happen is the PC transfers this to the MAR. So there's 10 here, and then the MDR is going to store the instruction stored at the address indicated by the MAR, which means that so the MAR has 10, right? Which means that in this table here, it's going to have 7, 8, 9, 10. And at 10, whatever value is at 10 is what's going to come here to your MDR. Okay? So suppose in 10 you have the value 25. That means the MDR is now going to hold the value 25. And then this 25 is going to come to the CIR because that's the current instruction, right? And in between all this, the PC is also incremented by 1, which means 10 plus 1, 11. 11 is going to be your new PC's, the data in the PC. And then in the end, the CU is going to use the instruction in the CIR as input. 25 is going to be your input. Okay, so yeah, that's it for this whole chapter. And there's just one part left, which is interrupt handling, which will take like a minute to learn, but it is very important. So let's just do that. So interrupt handle, basically interrupt is a signal or event that temporarily halts the normal execution of a program. Okay, and this allows the processor to handle a specific task or event. Like suppose if there's an error, right? So the system is gonna send an interrupt signal, which is gonna temporarily halt whatever program was currently running. Okay, so when there is an interrupt, what happens is the contents of the register is moved to memory temporarily. Okay, so the contents of register is moved to memory temporarily. Okay, everything that was in the CIR, PC, whatever, it's all going to be moved temporarily to the memory. Okay, and then the interrupt service routine, or ISR. Okay, interrupt service routine is triggered by loading its initial address to the PC. Okay, the ISR's address is going to be loaded to the PC, and after the ISR is executed, if the interrupt is handled, yes and no, right? Sometimes the interrupt might still not be handled. So if it is handled, then you're gonna take whatever was in the memory, the stored contents of the register stored in the memory is gonna come back to the register. Okay, from the memory, it's gonna come back to your register, and then it will resume execution. Okay, otherwise it's gonna repeat. If there's still an interrupt, it's gonna repeat the execution of the ISR. Okay, so that's it. Another thing is register transfer notations, and there's only two things you need to learn here. basically it's like a pictorial representation, or it's a representation of what exactly happens. So for example, if I say MAR and then PC, what does this mean? This basically means whatever data is inside the PC, that address is going to be sent to MAR. Okay, if I say PC is PC plus 1, then this means that the PC is incremented. Now sometimes you might observe that, okay, let me just write an example. There might be two square brackets. Okay, what does this mean? It basically means that the contents of the address is moved to whatever is given here. Okay, so far this was just PC to MAR, just means that the address is sent there. But if there's two square brackets, that means that the data inside this address is going to be sent to the MDR. Okay, and then another thing is, sometimes in one line itself there's going to be a semicolon in between, and then you might write this MDR MAR thing. Okay, what does the semicolon mean? It basically means that two operations are running simultaneously. All right, so yeah, that's it for this entire chapter, and I will see you guys in the next video.